Okay, so let's try this again. You, in your comp book, you should have written down this information because we're going to cover this in combination with your periodic table that you're supposed to have, which is your paper that you're going to have with you all the time, basically in this corner, that's going to help you along. So you should have already copied this information into your composition book, and so we're going to look at that information with your periodic table of elements. Now, this is the periodic table of elements, and it is zoomed in, so I want you to look at this part right here. And there's going to be times where you're going to have your periodic table with you and not your comp book, and then there's going to be times that you're going to have your comp book and not your periodic table. So it's important that you have the information in both. So one of the first things that you guys wrote down was that the atomic number equals the number of protons. Now, we discussed a little bit yesterday, not only does it tell us the number of protons, it also tells us the number of electrons, okay? So 6 for carbon, it means that it has 6 protons and 6 electrons. What does the mass tell us? What does the atomic mass tell us? Jakari. Yeah, protons plus neutrons. So the difference between the atomic number and the atomic mass is that the atomic number tells us that there are 6 protons and 6 electrons, and then the atomic mass, a total of 12, that when you add protons and neutrons together, you get 12. So that doesn't necessarily mean that there are 6 protons and 6 neutrons. It just means that together they make 12. Okay? So, and then it's always important that you have the same number of protons as you do electrons, making the atom neutral. Because what would happen if I had one more proton? What would be the overall charge of the atom? Michael? Positive. What if I have one more electron? What would be the overall charge of the atom? Larry? Negative. Okay, so it has to remain neutral. That's the main key, and that's why this number is always, you're always going to have 6 protons and 6 electrons when you're talking about carbon. Now, the mass, when we start doing atomic math in a minute, it's a pretty big decimal, okay? So what you're going to want to do is round to the nearest whole number. So make sure that every time you're doing the math, you're going to round to the nearest whole number. So what would the atomic mass of carbon be? 12, because the number next to it is a 0, which means we round down. Okay, so let's go back to the PowerPoint, and this is basically what we recorded or just wrote down on your comp book. But like I said, you're going to want to make sure that you have this information not only on your periodic table, but you're also going to want this in your composition book. So you're probably going to want to write this right below the notes, just the information that you just wrote. Draw it just like this and copy it into your comp book so you have an easy and quick reference for later. Okay, so after you've copied down that diagram of just the basic information about an element box, I want you to go ahead and copy down this as well. And this is going to be our first introduction to atomic math, and I'm going to show you. Now, as you're going along, if you find that you can fill things in before we actually talk about it, go ahead, because we are going to talk about each part of this. You're going to see a quiz that's very, very similar to this, the same layout. So you're going to want to make sure that you understand this, and when we start to practice it, so that when you get that quiz in front of you, you're ready to go. Okay, so basically the first thing we're going to focus on is, again, the labels of the element box. This is exactly what, or close to what, every element box on every periodic table is going to look like. So the 8, what is it pointing to? What is that called? Atomic number. Okay, what about the O? Symbol or atomic symbol or element symbol, any of those would be fine. It's interchangeable. What about oxygen? Name, element name. That's what I like. And then the last number, atomic mass. And then what are we always doing to the atomic mass? Rounding to the nearest whole number. Okay. Then let's look over here, just a little reminder. Atomic number equals the number of protons or electrons, not and. Make sure that you understand that that's an or, okay? Then down below you have the atomic mass equals the number of, tell me, protons and neutrons together. All right, so basically what we're doing is we're filling out the information based on what we know. Okay, so we see that number 8, like pretending that we don't see it up here. How could I figure out what element number 8 is? Where do I need to look to figure out the name of element number 8? The periodic table. And if I look at number 8, I'll see that 8 is oxygen. Okay. What is oxygen's atomic number? 8. The atomic number up at the top is 8. What is oxygen's atomic mass? 16. Thank you for raising your hand, Andre, and being the only one. Okay. If I know the atomic number, what are the two other pieces of information that I automatically know? Protons and electrons. Okay. So immediately I can fill in protons and electrons because I know that the atomic number is 8. So I can go protons are 8 and electrons are 8. Okay. How do I figure out the number of neutrons? What do I need to do to figure out neutrons? Because there's no number in the element box that tells me just neutrons. Okay, Destiny. I need to divide. Okay, if the atomic mass tells me protons and neutrons together, and the atomic number tells me just protons, what do I need to do, Jakari? I subtract. So I subtract 8 protons from the atomic mass. See how this is set up as a math problem now? 16 minus 8 equals 8. So I know that oxygen has 8 neutrons. It doesn't always work out like this, 8, 8, and 8, okay? Do zinc, okay? Do zinc on your own. Okay, so let's take a look at zinc. Tell me the symbol for zinc. Eric. ZN, okay? We're going capital Z, lowercase n. It's really important that you follow the capitals in lowercase. If you had 2 capital letters, fix it. Because anytime that we're doing chemical formulas, a capital letter indicates a new element. So if you do everything capital letters, you're actually, if you had capital Z and capital N, you're indicating 2 elements. So make sure that you do, anytime there's a lowercase, make sure that the lowercase is present in your symbol. On top of that, don't always assume that the symbol matches the name of the element, because sometimes they're named after the people who discover them. Okay, so what is the atomic number of zinc? The atomic number of zinc, Andre? 30. What does that tell me? What does that tell me? It doesn't just tell me the atomic number, but what does the atomic number tell me, Eric? And the protons and electrons. So immediately I can just fill in all 3 of those lines at the same time. Okay. What is the atomic mass of zinc? The atomic mass of zinc. Joule. 65. So now I have my math problem. Okay. 65 minus 30 equals 35 neutrons. Done. How many people got that right? Excellent. Okay, do the next one. Okay, so let's look at this next one. What is the symbol Li stand for? Jacob. Lithium. Okay, So what is the atomic number for lithium? Laura. 3. So what else can I fill in if I know the atomic number? Larry. Protons and electrons, okay? What is the atomic mass of lithium? Jared. 7. You're going to round up because it's 6.9, so you're going to round up to the nearest whole number. So then we're going to go ahead and figure out our neutrons. 7 minus 3 is what, Andre? 4. And then we're done. How many people got that one correct? Good. All right, so we're going to move on to a little bit more practice with this. How many people look at the periodic table and find it kind of intimidating? It's a little scary, right? Okay. Does anybody know what the name, the periodic table of elements, even comes from? Like what it means? Okay, obviously what's on here? Elements, okay? Periodic table is a way to organize information. And just a couple things that you need to know about that is we already covered what I wanted you to write here. But all of this information is actually organized in a way that it helps it group similar properties together. So if we look at the first column, this is what we call any column is called a group or a family. Okay? And what that means is that all of these elements in this column that I'm pointing to have similar properties. All the elements in this column have similar properties. So that's what we call a group or a family. So columns are groups or families. Rows, which go horizontally, are called periods, and that's where the periodic table comes from. So every element in a row has the same amount of energy levels. Now, we talked about energy levels yesterday when we were talking about Niels Bohr. And today, you're going to kind of learn how to do a Bohr model, okay? So, let's pop over to this. You do not have to write this down, okay? You are going to have to practice, but you don't have to write it down. Okay, so the first thing you need to know is that in the model of when you're making a Bohr model, it has energy levels. Okay? Trying to make sure it fits. Let me do this. Make it big for you. You're going to need... Maybe that's better. There we go. You're going to need to know this information. This you do want to write down. Okay, it's the only thing you have to write down about Bohr models right now. The level 1, which is the first energy level that holds electrons, holds a maximum of 2 electrons. Level 2 holds a maximum of 8 electrons. For our purposes, level 3 holds a maximum of 8 electrons as well. And then level 4 holds a maximum of 32. Make sure that this gets into your comp book, friends, because this is information that you are going to need to know backwards and forwards. Okay, so what these rows or the periods show us is that each row on the periodic table tells us how many energy levels we need to draw for our Bohr model. And all you have to do is look across, like how many elements are in the first row of the periodic table? How many are in there? In the first row? 2. Hydrogen and helium. Okay, and do you see the number to the left of the hydrogen box right there? And it's a tiny little 1. Okay, and then you move down. All of those elements have 2 energy levels. All of these elements have 3 energy levels. All of these elements have 4 energy levels. And if you keep going down, we go all the way down to 7 energy levels. We're only going to be working with the first 4, which is why I only gave you the information for the first 4. Whoops, I want to zoom in, not zoom out. And we're going to practice how to do a Bohr model. Okay? So the first thing you're going to do is you're going to find out, we're going to do hydrogen. And the first thing you're going to do is copy the symbol of that element. So what is the symbol for hydrogen? H. So you write an H. How many energy levels does hydrogen have? 1, because it's on the first period. So I draw 1 circle. How many electrons does hydrogen have? 1. So I draw 1 electron, and I am done. Super easy, right? Okay, so I want you guys to go ahead and try lithium on your own. Okay, so what's the first thing I need to do to make the Bohr model for lithium? Johnny? Yep, write down the symbol, which is uppercase L, lowercase I, just like that. Okay, so you should have the symbol in the middle. How many energy levels does lithium have? How many energy levels does lithium have, Aspen? 2. So I'm going to draw 1 circle and then 2 circles. Just like that. How many electrons are on the first energy level, Jakari? 2. Can I have more than 2 on the first energy level? No, I cannot. Okay, so now I'm going to go ahead and put my third electron on the second energy level, and it should look something like this. Okay, how many people had that on their paper? Okay, so here's what we're going to do. You guys are going to practice doing Bohr models, and you're going to do the first 20, and I'm going to show you how to set up your comp book in a minute, okay? So you're going to open up to the next full page in your comp book.